afternoon, everybody. We will start with this particular program today. It's on surface electroplating, basically. Little bit of corrosion we will be covering in this. Conductivity of that is higher than the purest form of water, that is either DM water or DI water. Rectifier supplies positive charge to the anode, which helps the metal ions to get deposited on the cathode. The rate of deposition depends on the current density through this rectifier. More the current, more is the thickness. Advantages of electroplating: good service life and corrosion protection, aesthetics, abrasion resistance, chemical resistance, sometimes weldability, solderability, conductivity, electrical conductivity as well as heat conductivity, self-sacrificing properties. This is basically to give you excellent corrosion resistance, barrier layer, migration resistance, thickness building, engineering and mechanical properties. Limitations of electroplating: the electrolytes are hazardous and poisonous. Extensive effluent treatment is needed, and that is the basic very big problem as far as the plating shops are concerned. If the shapes and sizes of anodes and cathodes are not appropriate, that is the surface area of anode and surface area of cathode are not appropriate, not calculated, the deposited thickness can vary. Component needs to be conductive, cannot be processed on site. This is one big limitation. Painting you can do on sites, powder coating you cannot do on sites. Likewise, plating also you cannot do at sites. Electroplating purpose: to improve aesthetics, corrosion resistance, abrasion resistance, chemical resistances, weldability, solderability, special surface properties, and engineering or mechanical properties also. So now in plating process, for the first one you have is surface preparation before plating. This is to remove the roughness and rust on the surface. Then we have cleaning. Jobs reaching plating shop have a good amount of oil, grease, coolants, dust, dirt, etc. attached to it, which needs thorough removal during cleaning. So that is you can say as degreasing and cleaning. Third is rust removal. So jobs would have rust and scales, that is mill scales, so what you normally find on structural steel as well as on hot rolled materials, or sometimes scales do appear after heat treatment. These needs to be removed or eliminated completely before we can do a good plating. So this is also very important. After that, coating, that is actual electroplating, and the last one is passivation. In passivation, the reactivity of plated metal, that is the metal which is plated on the surface, is reduced or is eliminated. Zinc electroplating. Purpose is zinc plating protects steel by providing physical barrier as well as cathodic protection, or it is also called as sacrificing property. Zinc plating can have ultra smooth finish. Zinc plating provides a soft decorative finish. Zinc corrodes before the base metal to protect it by sacrificing itself. Purpose of zinc plated products vary from industry to industry. The requirement vary a lot. Properties and benefits of zinc plating. Zinc plating is economical, probably the most economical plating you can have. It can substitute cadmium plating. Now cadmium is having pollution issues, so people are moving to either zinc plating or zinc alloy plating instead of cadmium. It has great ductility and adhesion. It is suitable for rack and barrel type of plating. This is rack type plating. This is barrel type plating. It has good corrosion resistance, good wear resistance, and good tarnish prevention. Tarnishing normally happens in case of silver plating. You find it the most. Then you find it on copper plating. Tarnishing happens, which is a natural process again. Industrial segments, popular segments are automotive, aerospace, general engineering, electronic and telecommunications, heavy equipment and hardware. Okay, so now we will be moving to the next topic, which is nickel and copper plating. Nickel, first we'll start off with nickel plating. Now, nickel and copper both are base platings, you can say, for various other platings. So that we will discuss in this presentation. It is a technical of applying a thin layer of nickel on a job. Nickel layer can be a decorative layer as well. It provides corrosion resistance as well as wear resistance. Also used for building up thickness on worn or undersized parts for salvage or repair work as well. Parts to be plated must be clean, free of dust, corrosion and defects before plating, as usual, and which we have discussed for other platings also. Once the job has been prepared, it is immersed in electrolyte solution and is the cathode. The nickel anode dissolves into the electrolyte to form nickel ions. The ions travel through the solution. So this is a nickel plate or nickel anode, and they will move to this particular cathode and get coated. Engineering nickel is used where the brightness is not desired. Non-decorative applications provide wear and corrosion protection as well as low stress buildup and dimensional recovery. The method can be used for making wear resistant coating also, which is normally we call it as hard nickel or engineering nickel. For decorative applications, decorative bright nickel is used in wide range of applications. It is often offers a high luster finish, corrosion protection and wear resistance. In the automotive industry, bright nickel can be found on bumpers, rims, exhaust pipes. Now bumpers are non-metallics nowadays, all are plastics, but it used to be there. Exhaust pipe rims. It is also used for bright work on bicycles and motorcycles. Nowadays, most of the motorcycles, because of plating restrictions all over, have shifted to black powder coating or something. But still, some of the classic vehicles you can see in the market are plated with nickel or nickel chrome, which we will be discussing later. Decorative applications, other applications include hand tools, household items such as lighting, plumbing fixtures, wire racks, appliances, etc. Also used for tubular furniture and wheelchairs, etc. This is okay. Now we come to copper plating. This is the process of applying a layer of copper electrically on job. Copper ions form anode dissolved in electrolyte. These are all water-soluble salts, especially CuSO4, what we discussed earlier. The copper then physically flows to the job, which is cathode, and applies. It applies a thin copper layer on various metals for functional and decorative purpose. Copper can produce a dull, semi-bright, gloss or satin finish. Industrial application ranges from automotive to medical. Copper is an element with high thermal and electrical conductivity, and there is antibacterial and tough. It is antibacterial, tough and ductile. Now you can see on electrical connectors we use that. This is a purely decorative item. This is purely engineering item, and this you can see we have these at home. Copper bottom vessels where the heat distribution happens very nicely and even. That is why on stainless steel from outside usually we are applying this copper layer, which works better while cooking. Now we are moving to the next presentation, which is chrome, silver and tin plating. Now, as we have seen that in the earlier slide, either we use nickel or either we use copper as a strike coat. The coat which is the first layer, first coat, is usually we call it as a strike coat or a base coat. Like in paints, we call it as a primer and top coat. It's something like that. Now chromium is a bluish white and lustrous metal that is resistant to corrosion in most atmospheres. Chromium plating therefore is extensively used as final finishing operations. There are two types of chromium plating. One is decorative chrome, another one is hard chrome. So we'll discuss that in the later this thing. Properties of chromium: they have excellent heat resistance, excellent wear resistance, excellent corrosion resistance. They have a very low coefficient of friction. So normally it offers a very good lubrication kind of thing, self-lubricated thing. Hard chromium plating, due to higher thickness, the layer hardness improves the engineering properties. Now, in most of the machines where you have continuous abrasion or what we call as metal to metal movements, there usually hard chrome is preferred, like in pumps or like in reciprocating pumps or various other items. And these hard chrome basically will give the proper hardness and lower coefficient of friction, because of which the wear and tear is reduced to a great extent. Decorative chrome plating. This is very thin layer of bluish metal which is applied over a nickel strike plate as a thin layer, also called as a flash coat. So again the same picture which we saw earlier is nickel plating is 20 to 22 microns. So normally whatever imperfections are there on the substrate or base metal are covered here, and you get a very smooth and nice finish. And on top of it, you are usually getting 2 microns, about 2 microns of flash coat. We call it as a flash coat. It's again a electroplating layer, but it's very thin, so called it as a flash coat. And this particular coat, nickel plating, we call it as a strike coat. It is applied on its own. It is very porous. It has cracked and porous appearance when examined under microscope. Chrome over nickel gets higher corrosion resistance. Application of decorative chrome plating. Basic industries are automotive components, tools, kitchen utensils, hardware, and musical instruments also. So wherever you need higher corrosion resistance, where you need very high decorative looks, probably these are very useful and very highly used. Like when you go to buy taps and this thing, plumbing hardware, they call it as CP. CP stands for chrome plating. So these are all very bright chrome plated items like what you see here in this particular picture.